So I'm going to talk to you this evening about the AERALIS Modular aircraft. We actually don't have a name for it yet, and we're deliberately holding off having a name for it. So it's just the AERALIS Modular aircraft. And talking a little bit about the project and the program and who we are and what we're trying to do and what we think is the opportunity there, and show some of the progress that we've been making to date. Before we do all that, and just to sort of do some illustrations of some of the stuff that Caroline just outlined for you, just show you some pictures. So just to show you a little bit about my background, and the real reason for this is just to show you some of these pictures of some of these old aircraft that I worked on. So when I first went into BAE at Kingston, they were working very hard on this aircraft here, which is the P1216, which still looks very, very futuristic and modern. And that was the sort of the great hope for the supersonic STOL aircraft that eventually, after however many years it was, 25 years, became the JSF. But that was what BAE Kingston were working on at the time. And this was the aircraft I went out to work on in America when I first went there. But that didn't last looking like that for too very long, and eventually became after probably about 5 different projects became the F-35 JSF. And this is a picture of the model that I was sort of responsible for developing and helping to get moving, that did a lot of the hot gas ingestion testing, so the sort of ground effects area that I was specialising in at the time. And that's a rig that was originally at Kingston and is now at Wharton. Then involved in the Nimrod, and really the purpose of showing you this picture is to show the wind tunnel model in the sort of the inset, and then the actual aircraft as it came out. You can see the two are very similar, even down to the colour on the paint scheme. But really the thing to show you here is that we were doing the intakes there on the model were actually 3D printed. And this is in the sort of 1990s, just to show that there is nothing new under the sun. 3D printing has been around for a quarter of a century now, and has been used in anger for an awful long time. And then, rather strangely, after all of those sort of new projects and whatever, I actually got much more involved in the Harrier and helping to support the Harrier in service. It's sort of been in the background of what I've been working on for forever, but got much more involved. And actually, sort of finally, in the sort of early 2000s, we started to work out some of the reasons why the Harrier flew and did what it did. We just sort of accepted, oh, Harriers do this, and then after 20 years, you actually work out, why do they do that? And we actually worked out a few of the bits and pieces, but they're war stories for another time. 9 years at ARA here, and I think we've said enough about that. And then a little bit of Lilium on contracts, which was actually, and I got into that because of all the work that I'd done on the VSTOL stuff. So because of my VSTOL expertise, they came asking, how do VSTOL aircraft work? What does happen near the ground, and how do you do transition and so on? And then really, I guess, in bits and pieces, and for the last 4 years, and then this last year as a full-time employee working for AERALIS. So that's a little bit of my background, mostly in aerodynamics, as you can tell, and I'm going to focus a bit more on the aerodynamics this evening, because that's what I know about and what I'm comfortable talking about. So anyway, overall agenda, so the vision, the product, the company, developing the market. So we're trying to do something a bit new, and we're not designing an aircraft against a specification. We're actually trying to bring people along with us and say, hey, you could do this. That'll fit what you want, won't it? And they're saying, yeah, well, actually, we think it will, but can it do that? And can it do this? And so we're sort of in lockstep with our customers and potential customers, trying to develop the whole market. And I'll come into that in a bit more detail. Progress to date, current status, looking ahead. So an awful lot of these slides are corporate approved slides. I hope they all fit together in a coherent story. But one or two of them, tell me afterwards how well it worked, because we've got a whole bunch of slides, and I was trying to put them together to make the story that I was trying to tell tonight. So our vision, our overall vision, the modular aircraft concept. So what we're really trying to do is put in a significant cost reduction to provide capability. And when we say capability, so we're not necessarily just selling an aircraft, we're selling a whole system. We're selling the ability to train pilots, which includes an aircraft, but also all the bits and pieces around it. But the actual product, the flying product, what we're trying to do is maximize the commonality of structure, the systems that go within that structure, the various parts and so on, and then add on to that some modularity, so that we have a range of bespoke capability, but in a nearly common, a mostly common aircraft. So at the moment, the RAF have, and I can't remember the exact number, but they have an astonishing number of different types of aircraft, sort of like 17 different types of aircraft. Some of them only got 3s and 4s of, but they're all bespoke designs. They're all these exquisite designs. They're designed to completely fit a particular specification. But it's unaffordable to keep all that whole range of different aircraft, because you're only carrying spares holdings, for 3s and 4s, and it's very small fleets. And what we're trying to do is say, well, we can give you all of that capability. The aircraft might not be quite as good. They might only be 90%, 95% as good as the other ones, but you'll save an absolute ton of money on it. So that's really our vision. We're going to help to do that by using digital systems and tools right from the outset. So all of the new tools that we've got, the sort of PLM systems. I'm going to go into a lot of acronyms tonight, and I'm going to try and explain them all. But please excuse me if I don't, because it's the aerospace industry. We do acronyms all the time. So product life cycle management, PLM, got there in the end, and that whole sort of ecosystem of digital. If we do it right from the start, do it properly from the start, it should massively reduce the time and the cost of certification, which is a real killer in the aerospace industry at the moment, and then allow us to do digital twin for every aircraft that's made. So we track every aircraft throughout its life. We track its performance. We can do prognostic maintenance, that whole thing, which is happening in the civil field now already. But we're baking in right from the start, and then also using simulation and synthetics to help reduce the cost of training. So the core product that we're starting with has been identified as the advanced jet trainer, so similar to Hawk and Alpha Jet and so on. There is potentially a very large market out there. There's a lot of legacy aircraft all approaching retirement. There's been a few new aircraft that have come in recent years. I'm going to show you 3. So the M346, I still think of as a new entrant. It's probably about 15 years old now already. But this and then the Turkish Aerospace Industries Hürjet and the Boeing T7. I put it there, enhanced performance. They are very high performing aircraft. But that comes with a cost. So the M346 has 2 engines of the Adur class. So the Adur is the engine in the Hawk. Has 2 of those. So twice the original purchase cost and the running costs and the maintenance costs and so on and so forth. And then the Hürjet and the T7 both have F404, General Electric F404 engines, which are double the thrust. and more of the Adore, and then also have an afterburner on them. So that the performance that you get from that is, we think, is more than you need for a trainer. It's giving you performance that is useful in the light combat aircraft arena, or if you need to go supersonic, but actually isn't helping you in the trainer. So we think we've identified this sweet spot for the trainer, and what I'm showing you here is a plot of a thrust against weight ratio for the aircraft. Don't ask me in too much detail exactly how we've defined that. It's sort of at a training mission weight, rather than necessarily the max takeoff weight that the aircraft can cope with, and we've got a price for these out of what's available in this sort of open source. But you can see that there's a sort of a trend here that thrust to weight versus price, as you'd expect. There's a reasonably good correlation between the two. You can see that the Hawk and the Alpha Jet and the L-39 Albatross and the T-38, which are most, all four are fantastic aircraft. All four have been really successful over the years, and they're all sitting, down around here. And these new aircraft are up a much higher thrust weight, much higher performance, much more expensive, really a lot more expensive. But the Hawk and the Alpha Jet and so on have been really successful for a reason. It's because they're really good training aircraft. So we've identified that sort of thrust to weight ratio is really our sweet spot. So we're sort of operating in that triangle there, the red triangle. This enables us to optimize around that area. And I have to say that triangle is about 2 years old. We're probably a little bit sort of, we've moved it a little bit to the right and a little bit up a bit, but not very much. And we're still in the process of refining that. But that allows us to, with our modularity, it allows us to then go down a bit, both in thrust to weight and other aspects of the aircraft, to compete in the BFT, which is the basic flying training area, where we have the turboprops typically at the moment. And also then with our modularity, we could move up into that region where these new aircraft are. So what we're trying to do is get a core product that is right in the sweet spot for traditional training, but also allow us to move up and down to other areas. And we're doing that with modularity. So take you through some of these, some of the things that we can change, some of the modules that we have and that we've identified. So we start off with the common core fuselage, so CCF, which I'll refer to on a regular basis, but that's common core fuselage. So it is the basic fuselage with the cockpit area and some our integrated modular avionics and our other aircraft systems that are in there. Now the graphics on here haven't quite kept up with where we are. So the current CCF has a bit more fuselage behind it than is shown there, but we're still working to the same basic principle. And then onto that CCF, you then add in, well, are we having twin seats which we would for a trainer, or should we take out one of the ejection seats and replace that with fuel? And so we have a single seat aircraft where we've got additional fuel and or other systems that we can put in there, or do we go completely uncrewed so we can have a remotely piloted or autonomous system, and then you get more volume for more systems and sensors and so on. The outer wing then is the next thing that we can change. So the basic outer wing, standard outer wing, is our advanced subsonic wing, but we could put on a whole range of different wings in there. We can change the sweep slightly, we can change the span, we flex the area. and we'll show you some of those in the next slide or two. And then finally, we need to put on an engine. So the basic advanced jet trainer is a single engine, so we have a single engine nacelle. But we could go for twin engines, or we could even put on a kind of the large engine. And so what we would be looking for with the large engine is something that's more like a biz jet engine. So thrust is very similar to the Adore, but actually a much higher bypass ratio, which makes it a much bigger engine. And if we do that, then we start to get quite significant endurance and range out of the aircraft. And so doing that sort of plug and play with the modularity then gives you, you can see some of the different types of aircraft that we can get out of that in these little sort of icons along the middle of that graphic. So the one that we're working on most heavily at the moment is the AJT, so Advanced Jet Trainer, or LIFT, which is a lead-in fighter trainer, or sometimes called a FLIT, quite a lead-in trainer, depending which day of the week it is. And then we have, for some reason, we pulled out the aerobatic team as well. So one of our ambitions is to see the red arrows flying in AERALIS aircraft. So basic trainer uses the basic trainer on the left there uses a straight wing and a detuned engine or a smaller engine if one ever becomes available. The AJT lift and the aerobatic team are using that's the one that I've been describing in more detail, but then we can also move on to operational training, light combat, etc. And then we go into some of the uncrewed aircraft. And the interesting ones here are the uncrewed I-Star and the uncrewed Tanker, where we're putting on a much larger wing, significantly increasing the area of the wing. We're putting on that big bizjet type engine, and we can suddenly get 3 times, 4 times the endurance out of that, and we can do quite a successful mission. Still using that same common core fuselage. Really quite interesting just how much you can get out of that once you start playing around with the wing. And the idea is that you just unbolt one, bolt one on, is the idea. I'll show you a little bit about that later. I think this probably says very much what I've been, or summarises some of the stuff I've been telling you already. So common core fuselage, but the really important thing in here is that, you know, for all these aircraft, and even when we have lots of different wings that we can bolt on, we use common systems. We're going for fly-by-wire flight control system. So that simplifies the bolt-on, bolt-off area. But we also use the same actuators. So whichever wing we're using, we use the same actuators. We're trying to minimise that footprint. So maximise the commonality across all of the different variants. So the sensors, the actuators, so we have the same flight control computer throughout the whole, all of our, or set of flight control computers for all of our variants, but we just changed the flight control laws. Okay, so hopefully there's no software people in here are going to tell me you can't just do that, but you know, it is an awful lot simpler than doing bespoke for every single variant that you do. And then this sort of, I don't know if any of you in the audience or listening in have heard of Pyramid. It's an open system architecture. It's sponsored by the MOD. There's an awful lot of work going into it at the moment for the FCAS project. And we're one of the trailblazers on Pyramid, which should also, you know, help with the modularity side of things. So AERALIS is a company, UK based, privately funded. What we're trying to do is you know, there's a huge amount of aerospace industry within the UK. We're not making many whole aircraft in the UK. We're doing a huge amount of work for the world. And one of the really interesting things is when we start talking to some of these really small niche companies that we've been speaking to, that they're doing work all around the world. And what we're trying to do is leverage on that to make best use. And what you can see on the map on the right is a selection of the companies who have done some work for us. Some of them are no longer under contract. Most of them still are. But going from really small companies, that fine unit based in Scotland, really small. I was going to say one-man band. There's 4 or 5 guys together as a collective who are doing really good structures and stress work. Swift Aircraft in Norfolk, who have been in the news recently with their very basic trainer. They've done quite a lot of work for us on design and CFD work. ARA here, who I'm working with very closely at the moment, helping to develop the aerodynamics. Bigger, more well-known companies like Martin Baker, Thales Simulation, Hamble Aerostructures, and then a cluster around the Bristol area, which is where AERALIS have their main office. So people like Sterling Dynamics, Filton Systems Engineering, Novel Engineering, fairly small companies, but they're actually working, on products in Turkey, in China, in France, in the UK. That they are world renowned companies. As a company, AERALIS wants to stay small. We don't want to do everything. What we want to do is be the integrator, and so to make use of this fantastic infrastructure within principally the UK, but we're not confining ourselves to the UK. But that's where we look first, because closest to home is easiest. So hoping that they're going to be taking on significant shares of the work, and then because we want to be able to sell to the world. We know that if you want to go to the States or you want to go to various other places in the world, they will demand that they do a portion of the manufacture and quite possibly the final assembly as well. So that's all part of our strategy, and we're building that in from the start. It's not going to come as a surprise 3 years down the road when we're trying to sell to somebody. They say, "Oh yeah, but we want to do some of this manufacture." We're building that in right from the start. I talked a little bit about developing the market. So our product is versatile, the market is large, etc. The bit that has taken longer, I guess, for us to really get our heads around than we had hoped was this no fixed requirement set. So we're not designing to somebody else's specification. We haven't seen a spec come out and we're designing an aircraft to it. We've got this great idea. We think we know what you want, but it's no good going to the RAF or to whoever and saying, this is what you want. You've got to say, we think this might be, this might fit the requirement that we think you've got. And you've got to start that two-way engagement, and you've got to listen. It's no good keep on saying, yeah, you say all that, but what you really want is one of those. That really doesn't get you very far in the defence market. So we're engaging with a number of customers. And one of the things that surprised us is we thought we'd identified that there's going to be this trainer replacement market coming up. The market has come to us a lot quicker than we thought it would. There's a huge number of RFIs, requests for information, that have come in much earlier than we thought they would. So the trainer market is big. And we've got to be talking to all of those, try to make sure that we've got a product that is good enough for most of those people, but not tying it really closely to one particular requirement, because that's a surefire way of making sure that it doesn't meet everybody else's requirement. Yeah, that's one of the corporate ones. I'm not sure how much more I should say on that, or can say on that one, but it has been really interesting. this sort of understanding how the requirements are changing, or fitting ourselves in with some of the RFIs. So going to some of the progress, hopefully I'm not taking too long. So one of the interesting things was, so we've got the CCF. We say, right, okay, the core product is going to be an HG aeroplane, and we think that probably then if you put a much bigger wing on it for an I-Star aeroplane, or you know, something that's got long endurance, it's probably going to be okay loads wise. Well, we've done enough work now to say, yep, actually that worked. So 8G for the AJT and 5G for the ISR, actually the loads envelopes are almost identical. There's hardly any difference between them. So we've got a joint here. That joint, you can size it for the 8G AJT, and it's good for pretty much all the other variants that you're looking at. Similarly, if you're playing around with sweep a little bit, you're changing the center of pressure, so you're changing where the allowable center of gravity is. That looks like it's going to be manageable. You know, that we weren't sure about that to start with. So not only in flight, but also with the sort of positioning of the landing gear. So you've got to make sure that the landing gear is positioned far enough back. I was trying to make sure I remember which way around this goes. Far enough back that it doesn't tip onto its tail in certain circumstances, but far enough forward that you can actually lift the nose to actually take off. So, but all of that, you know, looks like it works. We've taken through an initial design of the MTA. And this is going to be new to everybody in the room, even those who've been working on AERALIS, because the MTA was only so named on Monday of this week. I'm not going to tell you what it was called before that, but it's very similar. But yeah, the modular technology aircraft, which is our first to fly. So this is sort of proof of concept, first to fly. We've taken that through to gate review, and that's sort of the digital mock-up, the DMU, the digital mock-up that you can see on the right there. Which has actually taught us an awful lot about the aircraft and has shown us one or two things that don't work, as well as the majority of things that do work. And has given us this sort of much greater understanding of the sort of sensitivities, the design space, the trade space that's available, and which we then can take back to the customers and say, okay, so what you really wanted was this, or you wanted, you know, 3 different types that could do this, that, and the other. The trade between those is, you know, we now have a much better idea. And so, well, sorry, I was going to tell you a little story there, but I'll wait until the appropriate slide for that one. But what we've actually discovered is that although we had a sort of path through to first flight and everything was going to go, you know, in a big long rush, we're currently in a little bit of a pause, because we've discovered that actually what we've discovered using taking this aircraft through to the design maturity that it is actually changed the conversations that we've been having with our customers as to where the design trades are, or the trade space is. So I'll just take you through some of the features then of the, didn't change that slide. It's the modular technology aircraft, not the modular concept aircraft, the MTA. So we have cockpits, 2 cockpits, size for JPATS 1 to 6. So JPATS is an American standard that was sort of defined probably in the late 70s, early 80s. But anyway, it defines sort of extremes of aircrew in terms of height, weight, reach, leg length, whatever. I mean, it goes into a lot of detail. 1 to 6 goes from basically gorilla down to really quite petite female frames, and is quite difficult to achieve a cockpit that can do all of that. There is actually a JPATS 7 as well, which is even smaller. And what you find is that so the really big guy, you've got to make sure that when he ejects, you don't kneecap him with any of the so the wide area display that we have, for the screen. So you've got to have enough room that he doesn't get kneecapped as he gets ejected. But then the very small framed person, I assume for the sake of this is a woman, has a problem with reaching the display, and actually getting a cockpit that can serve all of those and still be safe for ejection is pretty tricky. So certainly the seats, the ejection seats that we have for the first aircraft are only JPATS 1 to 6 compatible, and so at the moment our cockpit meets 1 to 6, and we're working hard to try and get to JPATS 7. So ICY, interchangeability, the sort of thing that in almost every aspect of life you'd expect nowadays, that if you have a spare part, you come to put it on and it just fits. Things just are interchangeable. Unfortunately, in aerospace and aircraft structure, that's pretty uncommon, and there's an awful lot of fettling and lining things up and difficulty in joints. We have to make sure that we have interchangeable joints, certainly for the empennage, and I'll show you a bit later for the wing as well, that we can pull off, unbolt, disconnect, pull off an empennage and put on a new one, and everything lines up and it just goes on. So we have an ICY joint for the empennage. We have ICY joints for the power plant pod. So the pod itself will allow us to change engine type, but it also has to allow us to change engine of the same type much easier than taking off the whole pod. So you have to still be able to take an engine out as well as change the whole pod. ICY joint for the wing panels. Slotted flapper on. So the landing gear that we have is in a sponson. What this does, it's very nice for leaving lots of volume within the structure for fuel, but the sponson itself has taken up a lot of the trailing edge that we need. So we don't have enough trailing edge for the flap that we need. So to get the lift required for landing, we use almost all of the trailing edge that's available on the outer portion of the wing, and there's not enough space there for the aileron. So we've got to have a flapper on, and it has to be a slotted flap as well to get the CL max that we require. So that's an area that's taking a fair bit of work to optimize, but actually we've got a system that seems to work. So main landing gear, because it's external to the structure and it is literally sort of bolt on, and the sponsons themselves are very lightweight, that means that we can actually replace those for a future carrier capable aircraft. So that's one of the ambitions that we've got, is to be able to make the aircraft carrier capable. And to accommodate that, we've also made the nose gear bay large enough for a carrier capable nose gear. And then we've also made the nose itself big enough to take a radar for when we get to those aircraft, those variants that require a radar. Our trainer doesn't need a radar, even though we will do radar training for our crew, because that's all going to be done synthetically. So you can actually beam in to the cockpit display what the radar would look like, and that's done from the ground, saves an awful lot of money. Just a little bit of detail on the power plant pod. So number of different engines that we want to be able to accommodate. They all have slightly different mounting arrangements. So you have to have an adapter plate or an adapter of some description between them, and the adapter takes the unique part of the engine and then goes into a common set of mounting points on the rear fuselage. Looks reasonably straightforward there. It's not. I'll just talk a little bit about some of the aerodynamics and the flight dynamics as an example of some of the work that's been done. We've done a lot of work in lots of these other areas. This is the one that I'm more comfortable with. So, and I probably should have done these columns the other way around. So there are some indicative requirements that we've got from a number of these RFIs, and they have they cause you to focus on certain particular traits, certain particular areas, certainly within the aerodynamics. So maximum speed that these RFIs are asking for is in the region of 0.85 to 0.9, which is causing us to look at the drag rise back number, enabling us to get the top speed that we require. Now, those of you who've worked in transonic aerodynamics will know that 0.85 to 0.9 might sound like a really small range. It's enormous. There's a huge difference between 0.9 and 0.85, absolutely huge, and the implications of that are very big. So one of the interesting variants that our customers are talking to us about are in-service trainers. So keeping aircrew current trying to think how to describe it. So rather than being able to fly their Typhoons and their F-35s however many hours a month, which are very, very expensive, they want to be able to fly aircraft that are much cheaper to fly but have similar qualities, so similar handling qualities, similar systems, similar way of feel for the pilots. They can go, they can fly, they can experience G. One of the key things is being able to operate all the systems that you need to do whilst continuously pulling 3 or 4 G. That's something you can't do in a simulator. And our ability, because we've got a fly-by-wire system, and everything is sort of digitally enabled, we could make cockpits that look just like an F-35 or just like a Typhoon. And you can have these as a companion trainers, so the guys can keep their currency at a much cheaper overall cost to the Air Force. So how fast do they really want them to go? And the pilots, we've had a lot of spirited discussions. They all want 0.9 or 0.92, or they want to go really, really fast. What we're coming to at the moment is we're starting to be able to put a price on all of that. So the work we've been doing is saying, okay, so 0.85 is relatively straightforward. 0.9 is really quite hard, and this is what it means. These are the implications. Do you still want it? Do you still need it? How important is it to you? Because that's how much it costs you. STR, sustained turn rate around about 3.2 G at that flight condition. So we need to look at transonic maneuver. We need to look at the sort of drag that you get at the higher alphas, buffet, transonic buffet, and so on. And the guys here at ARA have been doing a lot of work for me, helping us to understand that and to try and get the predictions in there. So both those first two bullet points, I've been working very closely with ARA on that. And then final one is the sort of landing speed. So in the region of 120 to 140 knots. So to get that, you need to sort out your CL max at low speed. So that's where we came to the conclusion that we really needed a slotted flap, and we needed to use almost all of the available trailing edge because the sponsor was taking up too much, and the guys at Swift Aircraft have been helping me with that. Just a quick word on the flight dynamics. So we want a naturally stable aircraft, although it's fly-by-wire. If you're unstable relative to naturally stable, it pushes up the clock rate on the FCCs, the flight control computers. It makes everything much more difficult, much more expensive, and starts to change some of the architectures that you use. So we really didn't want to go unstable at all, and we were warned off that by a lot of experts. They don't go unstable. It really is a nightmare from the flight control system point of view. So naturally stable, and then we want to get at least level 2 handling unaugmented, and by unaugmented I mean so not getting help from the flight control system, so yaw dampers and other sort of auto trim and all those other helps. You want to have basically a good handling aircraft, and then the flight control system doesn't have to do so much work, and it's much easier and quicker to get it certified. I just coughed straight into the microphone, so apologies for people online. We've done a low-speed tunnel test this summer. This is the 12-foot by 10-foot tunnel at Airbus Filton. Spent a happy week there. Not doing a great number of different configurations, but just sort of trying stuff out and doing quite a lot of flow visualization. So it mostly confirmed the predictions, but gave us some interesting insights as well. So just going to show you a couple of oil flows. So these are speeded up oil flows. First one is an alpha of 12, where everything is behaving itself. I'll set it running. So as I say, speeded up. The tunnel speed is Mach 0.2, and you can see that we start off and pitch the aircraft pretty much at the same time as the tunnel is getting up to speed, but it gets up to speed very fast. And seeing it like this, I think, is a really interesting and really valuable way of understanding what's going on with the aircraft. And of course, not much is happening here because everything's behaving itself. So next one, alpha of 15, and everything doesn't behave itself here. So we've gotten beyond the point where interesting stuff is happening. And I think you can see we're getting some quite interesting little vortex here. We've got a separation line that's coming down the whole of the wing. The really interesting thing is you can see how unstable that separation is. So the dynamics of that are being picked out really nicely. And I've got tons of these. Spent hours and hours and hours looking through all of these. But anyway, they have helped us understand. They've helped us understand the data that we were getting out of the tunnel, the actual forces and moments and so on, but also a lot of the CFD that we've been doing. They sort of helped us with the understanding of that. I talked a little bit about the sort of using the digital tools and trying to use sort of the modern systems to help us with that, what we're calling sort of the single digital truth. So this is just an example of that, looking at sort of flight dynamics and flight dynamics model. So we get our geometry and weights and inertias out of our CAD. We get an aero database that's derived from the CFD and from the wind tunnel test. It all goes into this configured system, goes into a single flight dynamics model that we have, just the one model. That's all there is, and that allows us to do the offline analysis, the offline simulations. It's the model that's used throughout all of the integration with the flight control laws and the flight control system, and it also allows us to do real-time simulations. And so we've been working with Thales simulations, so we're going to get full motion simulator through them, but also this sort of what we're calling lo-fi hardware, this sort of desktop simulator that we've got running, and everything runs off exactly the same model, the same the same engine, same software engine. It's the only one there is. You can't get it wrong. There's no translation between different models. It's the only one there is. So we've got this single thread, everything's traceable, and we're doing that with every system throughout the whole aircraft. So the fuel system and the hydraulic system, there's just that one thread. Everything actually comes together. So even within the TALIS simulator, they're taking those models of the hydraulic system and the electrical system and so on, which should significantly increase the pace at which we can do certification. So that's some of the progress we've been making, the status of where we are. So we're developing the market. We've got this sort of deeper understanding of the trade space that's helping us with our engagement. So there's an awful lot of dialogue going on with a number of potential customers. We are honing the design. So having taken that one design that I showed you through to that gate review, it's not going to look, it's probably not going to look exactly like I've shown you tonight, because it's given us that understanding of what really worked, what didn't work as well as it could have done. And it's now that we know more about the market than we did when we started the design of that, we're changing a few things. So as I say, assessing whether to make tweaks, the answer is probably yes. It's just quite how many tweaks, and we're not ready to tell the world what they are yet. But it's all about optimizing that sweet spot. So can we get a design that will sell really well for the AJT and gives us the jumping off point, the right jumping off point? Because if we go too far one way, it destroys the market. The other way, if we go too far, down, it destroys the market up. So that's really where we are in the status. And then looking ahead. So we're continuing that engagement with potential customers. We're very close to being in a position to ramp up the design effort. So and we're talking, I'm hoping it's weeks, and handfuls of weeks that we're going to be making the decisions on exactly what does MTA look like, and getting a lot of those partners that I showed you, and one or two others who we're in discussions with at the moment, getting their design teams ramped up, starting manufacture flying. The graphic on the right shows a timescale. I think it might be slightly out of date. I think it's slightly stretched beyond that at the moment, but only slightly. It's the intention is to do this fast. We're small, we're agile, we've got all the right tools that allow us to do it. We can be fast. That is the end of my talk. I'm very happy to take some questions.
Question from the audience.
Thank you very much. Very interesting and clearly a good move in the modular concept. We did it with engines many years ago, and I realize there will be limits. If you go for a very advanced high performance one up in the top right hand corner of your graph, how are you going to cope with the area rule, or is the fuselage shaped so that it will blend that way automatically?
How many hours can I talk to you about that? We've so very good question. We have been area ruling. The really key thing is to try and get everything. So we've been concentrating quite hard on the design of the one aircraft, but we've always been saying, a lot of people on our shoulders saying, Don't forget about the high performance one. Don't forget about the long endurance one. Don't make sure everything is still in there, which is complicating the design and slowing us down a little bit. So we have been area ruling the fuselage as it stands at the moment, even though we don't really need it for the AJT. There is still a bit of a debate as to whether we'll ever want to go supersonic, and a few of us are trying to say no, we don't want to, because that will really possibly put too many compromises into the basic airframe. But yeah, it is something that we've been playing with, and Adam here can take you through some of the stuff that he's been doing for me on area ruling. Chris.
Fascinating presentation, Peter. Really exciting project. I was intrigued by your comment about how you may be looking at making the aircraft more lightning-like or more typhoon-like. Can you say a little bit more about how you might do that?
There's a flippant answer and there's a really tricky answer. So the flippant answer is, well, because we've got a wide area screen display, so we don't have lots of knobs and dials. So it's a TV. You can make it look, how you want it to look. So you can make it look like a Typhoon, or you can make it look like an F-35. Of course, you have to get BAE or Lockheed Martin to tell you exactly how they look and how they do it. But I guess you get into that situation if that was truly what you were doing. They would be forced to by the overall customer. You can make the so we're going for side stick controller for the stick, and obviously for the throttlers on the side. You can just put on a stick and a throttle that looks and feels and has switches the same as those two aircraft. There's a flippant thought that says, well, you just take one off and put the other one on, and it's all software anyway, isn't it? And that's fine, isn't it? Certification wise, probably not. It's probably not quite as straightforward as we would like to think, but it's still there. And then because you've got flight control, a digital flight control system, you can actually make it fly a bit like it. You can actually make the handling if you wanted to. And again, you can do anything with time and money, can't you? And because it's all software, it's only software that's holding you back from doing that. And I know that again is a very, very flippant thing to say, because software is big and difficult to do. But so those are some of the ideas, and again it's discussing those with the customers, so that they say that's what we'd really like. You say, okay, so the cost of that is, we can do it all, but software, and it'll cost you X million. Or if you didn't want to quite have the emulation quite so good, it'll cost you X over 2 million, and they might go for the X over 2. But yeah, that's basically what we're the discussions that we're having.
Hi Peter, thanks for that. So many questions. Probably haven't got all night to do it.
Yeah.
Your flight test.
Mm-hmm.
Which country are you going to do your flight testing in?
The UK.
Really?
The I'm not sure what I'm allowed to say. I'll say it anyway. So we haven't signed any contracts with anybody, and we've been talking to a number of different people, but the favourite at the moment is Boscombe Down.
Yeah. Okay.
So we can do final assembly, so that they've got enough space. We can set up final assembly there. They've obviously got the flight test infrastructure there, so we wouldn't have to pay to set it all up for ourselves. So that's currently the favourite.
And your certificate to fly MAA?
Interestingly, neither MAA nor CAA feel comfortable and confident they can do it on their own, but they're really up for doing it together.
Right. Okay.
And
Yeah.
I'm surprised that's only like the third question, because normally the first question we get asked is, who's going to certify it then? Who's going to certify it? Yeah, CAA and MAA seem to be, and we've had a lot of discussions, and they're saying, yeah, we're up for this.
Yeah,
And
interesting.
they're really interested in the whole digital certification.
Part of the reason I ask the question, not so much just on the on aircraft like this, but I mean a lot of people do that type of flying in the US because it's just easier to do. It's easier to get that initial test flight certificate to go than it is in the UK, and that's just why I wondered if that was what your thinking was.
Yeah, the US seem to have slightly.
They're more relaxed for the flight testing because
I was trying
we've
to
got
think
a lot more desert, basically.
I was trying to think of the nice way of saying it. Yeah, you can get away with more, can't you?
Yeah.
In the US.
One last question while I've got the microphone. Just so I'm understanding, any single airframe, can it be modularized? Like, can you have the basic trainer aircraft one day and then a week later you could have it as an ISR airframe?
I'm glad you said only a week later.
Right.
Yes, the plan is that a week later you could do it. You will configure them on the final assembly line, and again, a lot of this is we're talking with different customers. So, how often will you want to change it? How often you really want to change it? We have had one or two who said we'd really like to be able to change it day by day by day, and that we don't think that's a sensible thing for this aircraft. There might be a follow-on aircraft where we'd say actually we can do that, but most. So one of the things we've been talking to is a sort of commercial provider of training for military aircraft. So the contractorized training, and so they might have a contract with country A for 10 years and with country B for 7 years, or in country C or whatever. And so they have a certain number of advanced aircraft there and a certain number of basic, and so they probably only want to change them, when their contract comes to an end, and then they'll reconfigure and send them somewhere else. So you're talking once or twice in the aircraft's life. But and I think that's most of the potential customers, but a few of them are saying, actually, on every 6 months maybe, or whatever, we'd want to change it. And it's changing the requirements for some of those joints. How often do you have to make and break a joint and all that?
Thanks.
And I think it's really interesting from a systems engineering point of view what you're trying to achieve here, because so my first question is, are you using model-based systems engineering, that more kind of open approach, rather than here's a doors module, here's a spec in a document, and just go and do it? And the sort of follow-on from that is a bit more, which I think you've touched on, which I think is really important here, which is my experience of working in defence and aerospace is you try and make progress in the engineering world, but the political landscape really shackles that and influences it in ways that are quite detrimental, and relationships can be very adversarial with producers and customers like that. So are you, with your approach to being more open with the customer and saying, rather than just telling us what you want, we'll figure that out, but you've got to come on a journey with us, and together we'll hold hands and sing Kumbaya and get there? And can you also sort of convince them at the same time, therefore, for your next aircraft, you don't have to put in all these additional requirements on, additional maintenance, because you'll be doing all this additional flying for training that can now live in this other space. So you're kind of pulling the expensive cost of running expensive aircraft for longer in the sort of more cheaper modular aircraft. So I suppose my question is, because I remember being at the aerodynamic conference 8 years ago, and a professor from America said, this industry is running away with itself in terms of cost. It's becoming unsustainable to keep doing this. It has to somehow change. And I sort of put to him, is it not the engineering, it's more the kind of procurement sort of life cycle that needs to really change? That's because you're bottlenecking what you can achieve with just sort of engineering anymore. It needs to move. So I suppose it's an open-ended question, but do you sort of see this kind of way of working as being a more sort of standard way that this industry may function, rather than sort of going back to these more entrenched, we're the customer, this is what we want, and you're just going to go off and make it, and then if we kind of disagree, then we're just going to fight?
My sense in the dealings that I've had, and I've not had nearly as many dealings as our sales team, obviously, my sense is that we are pushing an open door. I think, you know, the penny has dropped in procurement, that the old ways, we just can't keep on going that way, and they've been pretty open on the whole. I've heard one or two exceptions to that, but pretty much on the whole, the customer community that we've been dealing with has been pretty open, has been very supportive of what we're doing, and we hear sometimes that they're having battles, you know, back home to you know, get our way of doing it accepted. And that's just talking UK. We've also been talking very closely with a number of other countries, and on the whole, as has been reported back through the channels, that's all going pretty well as well. And people are genuinely interested and excited by what we're doing. We've obviously got to deliver, but if we can deliver, you know, they can see that what we're promising is a game changer. So I think I agree with you that the political side of things, navigating your way through that is always tricky, but yeah, genuinely the landscape does seem to have changed a little bit.
Okay, thank you. That's good to hear. 'Cause I was just going to say, like, I appreciate with your background, you've worked on aircraft for a number of years now. So when they were kind of a bit simpler, you could have got away with that approach. Whereas because it's just exploded in complexity, that might not serve its purpose anymore. So that's where it needs to kind of force a change from. So thank you.
Yeah.
Thank you. Are there any questions online? Okay.
Brian Hibbert, I'm the chairman of AERALIS. Come to keep an eye on this evening. But one of the things that really drove us to this at the very outset was cost of ownership. If you have an advanced and a basic trainer on this basis, you save something like 30%. And this has been independently modelled twice now. And the actual cost of ownership is many multiples of the cost of purchase. And you know, people around the world are realising that you just can't keep having these point design aircraft. And the concept here really came from Tristan Crawford, who worked with Airbus and then went to Kinetic. I don't know if you said that, but you know, and we're very much working really from a commercial model. You know, you go out to the market, everybody wants something a little bit different. When you sit down, you do that, and you go back to the market and say, well, yeah, you all want something different, but this is the midpoint, you know, or an area where you can all sort of operate, and you're getting this benefit of cost of ownership. And that really was the driver right from the outset. It's also worth saying that if you look at the pictures that Peter had up there, there's what looks like a pylon in the centre of the aircraft going along the fuselage. That actually is taken from thinking about an Airbus where you've got a wing, an engine hanging off a pylon on the wing. Basically, that pylon is built into the bottom of the aircraft, and that is patented. So that in terms of competitive advantage gives us quite a lot. So, you know, but this is much more about cost of ownership, cost of operation, than having some absolutely sort of single point aircraft that's different for every different person. And the market is really responding to that. And I think one particular country, when we presented this, I think it was presented actually in the States, and it wasn't the US company, but that country grabbed hold of our people at the end of the thing and said, look, come and tell us more about what you're doing. So you know, there's quite a big pull from the market. That's not to say that we can satisfy everybody's. But if we can get 80%, that's a very, very big market. Thousands of aircraft.
That was a very good talk, Peter. So Peter and I go back all of about 5 years, I think it was, when you interviewed me over in that building there for the ARA, and I've been happy ever since. So yeah, very good talk. Been working with Peter for about a year now on some of the aerodynamic stuff. It's a fascinating project that we're involved in. But I was thinking a few interesting points from the talk. I hadn't realised quite how high performance the T7 and the Hurjet are. They're right up in that top right hand corner, and I see where you're trying to be a bit above the Hawk, but down at this much further down. So that makes a bit more sense. From a technical perspective, obviously, I'm involved in the aerodynamics. It's good to see some of the market forces and what you're trying to achieve on the sort of wider context, whereas I might be a bit blinkered on the aerodynamics. It's good for me to get a bit of a view there. I like the way that AERALIS seems to be approaching the customer relationship. So rather than just like, this is what we got, take it, it's like we're actually talking and sort of communicating. And that comes on to the next bit where you've got all these different companies around the UK, and the relationship is good. I mean, when we've come to meetings down in Bristol, it's a very sort of genial atmosphere, and everyone's very much up for helping each other and sort of learning from each other, and it's very, very collaborative. The overall design, I think, is a good one. I think if you can patent, well, not patent, but if you can commission a Lego kit, then you'll make a fortune, I think, because kids will love pop the wings off, pop the wings on, and change the complete configuration quite easily. And yeah, so just a really good talk. So would everyone join me in saying thank you to Peter?